Alrighty then, corn children. Today is kind of a standalone lesson, even though it's connected to, man, thousands of things. We're just going to look today at this idea of something called combinations. Combinations, mathematically speaking, is a very precise meaning. We're going to get into that, but I need you to be aware that your combination locker is not a mathematical combination. That's like an anti-example. All right, so to kind of help you figure this out, we're going to look at an example. Here's the question. How many different ways can 4 pens be chosen 2 at a time? So we want to take these 4 pens and we want to look at color combinations. Only 2 colors being chosen at a time. So let's be logical. Let's suppose we want to start with the pink pen. So I can use pink to go with green. That is one combination of my 4 pens chosen 2 at a time, 2 colors. Or I could do pink with the whatever, lime green? I don't know what that is. That's a combination. Or we could do pink with purple. That is purple, trust me. So that's all the pink combinations. Chosen pink already. Now I want to choose combinations 2 at a time with these. So I could do the aqua green with the neon green. I can do the aqua green with the purpley one. All right, that takes care of all my green combos. Now, the only 2 pens left are the neon green and the purple. Now, I need you to be aware of something. When we do a combination, the order does not matter. So you see here at the beginning, I have pink and then the green. That combination would not be considered a different combination than green first, then pink. It's still the same 2 pens. In other words, if you're first, you're not special. Firstborn children take that to heart. All right, so with a combination, the order wouldn't matter. All right, so we've got 4 pens. We picked them and paired them together 2 at a time. And here's how many combinations we have. 1, 2, 3, 4, 5, 6. There are 6 different combinations. Now, with a limited number of combinations, it's not so bad to list them all out. But what if we had one of those ginormous packs of crayons that had like 7,000 crayons and we wanted to do them 3 at a time? That would get a little crazy. Man, if only there was some sort of mathematical formula to do this. I'm glad you think so too, because there is one. Again, the idea is this is a combination of 4 pens chosen 2 at a time. We're going to generic this up with some variables, and there is actually a formula. Yay! All right, so here's your formula. Get that out of the way, get that out of the way. Combinations. The way it's stated in most textbooks is going to be n things, that's like our original 4 total pens, chosen r, that's a lowercase r, at a time. We chose our pens 2 at a time. So 4 things chosen 2 at a time, n things chosen r at a time. With a combination, the order does not matter. Being first isn't special. All right, so first of all, notation, because we're not going to want to write that down every time. Way too much writing. So the first notation, and the one that we're going to look for on our graphing calculator in a minute, is NCR, capital C for combination. Slang when we speak is often N choose R. It is slang. Chosen doesn't necessarily imply that the order does not matter, but that's what your professors will say. N choose R. Now, that notation is on the graphing calculator. However, many textbooks use this notation. Parentheses, it's like a fraction, but there's no line in the middle. N over R. N chosen R at a time. All right, so what's the formula? Well, here's the formula. The formula is a fraction. in the numerator of the fraction is n. No, that's not n spoken really loudly. That is n with an exclamation point. That is n factorial. And I'm going to come back to that in a minute. What does that mean? We've never seen n with an exclamation point in a math formula. The bottom of the fraction also has those exclamation points, n minus r factorial, r factorial. All right, so what the Haiti-ho is n factorial? Again, I'm so glad you asked. All right, here we go. 6 factorial. I think if I do one example with you, you'll totally get this. Starting with the 6. It is 6 times 5 times 4 times 3 times 2 times 1. You don't go any further because if you do times 0, everything would equal 0. So 6 factorial, 6, 5, 4, 3, 2, 1, multiplied, not added, multiplied together. So let's check this out. With our little pen example, we did 4 choose 2, which is 4 choose 2 in the alternate notation. 4 factorial, 4 minus 2 factorial, 2 factorial. Just plug and chug. All right, here's your 4 factorial. 4, 3, 2, 1. 4 minus 2 you do in the parentheses first. 4 minus 2 is 2. So 2 factorial is 2, 1, and then another 2, 1. These cancel, those cancel. We end up with 2 times 3, which is 6, which is what we got when we did our color combinations. Yay! Man, this lesson is awesome. This couldn't get any better. Yes, yes, it could. It really could. Why? We have technology. If we want to do 4 choose 2 on the calculator, it will do this. We don't even need to know the 4 factorial over 2 factorial, 2 factorial, because it's going to let us type that in. No way. All right, if you need to, pause your little video and go find your calculator. Yeah? Did you go find it? Awesome. Here we are. Here's my calculator. It's awesome. It's not a color one, which is sad, but you know, it is what it is. First thing you're going to want to do, turn it on. Second thing you're going to want to do, you want to find this math button right over here, and you want to poke it. Poop. I wish it made sound effects. All right, those are your menus at the top. We are looking for the PERB. That stands for probability. We use combinations in probabilities. All right, so we're at the math menu now. You want to arrow over. I'm going to go left. Look at that. And here's PERB. Now you're going to notice a bunch of things on here. The ones that we are noticing are the third one down, not number 2. That's different. The third one down, NCR. Oh, and there's your exclamation point. Yeah, that's so cool. Now, when you're using these, especially if you have the 83s, both of these require you to enter a number before you use them. So you kind of have to remember and think ahead. If we want to do 4 choose 2, you're going to type the 4, then this, then the 2. Now, people with the TI-84s, you can go back and edit a little bit easier. So let's check this out. I'm going to go back to my home screen. So I'm going to do second quit. And if we want to do 4 choose 2, we type the 4 first. Haha! I typed the 4 first. Do you see it? There it is. I crack myself up. All right. Then here's your math button, your PERB submenu, number 3, and then 2. 4 pens, chosen 2 at a time. Booyah! So there's 6 different combinations of those pens. I made up the example. If you have the ginormous pack of crayons, let's say you have 700 crayons, and you want to know how many color combinations if you choose them 3 at a time. So 700 typed in first. You go to the math menu, the probability sub-menu, third one down. You can either type the 3 or scroll and enter. And then, what did I say, 3 at a time. That's a lot of color combinations. Ladies and gentlemen, this is how mathematicians, quote unquote, count things. We don't really count them, we use math. I know, it's crazy like that. All right, enjoy that lesson now.